Hey, Drew class, we're going to look at these problems that deal with how do I find the exact value of an expression when I have the cosine of an inverse trig function in here, or just any trig function of an inverse trig function. So the big thing, the key thing to remember here, and I talked about this in another video, is that the inverse trig functions are angles. So I'm going to use the angle notation, like theta is equal to the inverse sine of the square root of 2 over 2. And what that translates to is that the sine of theta is equal to the square root of 2 over 2. And when I have the output of a trig function, I can draw a right triangle and arbitrarily place the angle, and the sine of this angle is the square root of 2 over 2. Sine is opposite over hypotenuse. So this is the square root of 2, that's the opposite, the numerator, and then this is the hypotenuse, 2. That's the denominator. Remember, sine, right triangle trig says sine is opposite over hypotenuse. And then doing the math here, 2 squared, which is 4, minus the square root of 2 squared, which is 2, is equal to whatever this side length is, which is the adjacent side. I'll put A for adjacent, is the adjacent side squared. So 4 minus 2 is 2. The square root of 2 is the square root of 2. So this is also the square root of 2. Right, and now that, remember, this is the angle. So now I'm just trying to find the cosine of this angle. So the cosine of theta here, cosine is adjacent over the hypotenuse. So that is also the square root of 2 over 2. So sine and cosine happen to be equal here. That's not always going to be the case, but it is here when it's square root of 2 over 2. Alright, so check my answer. That's good. Now I do want to show you that you could do this on the TI calculator. Let me close this out so you can see the original expression. So I'm going to hit clear. Outside is cosine, so I'm going to start with that. On the inside I have the inverse sine, so it's second sine. And then type in your root 2 over 2. So square root divided by 2. Alright, close those off. And then I'm going to hit enter. Alright, there's a decimal. Again, do you recognize that decimal? That is the square root of 2 over 2. But if you don't recognize it, one of the things you can do is square your answer. Again, when you're finding output of sine, cosine, tangent, secant, cosecant, oftentimes they're either fractions like a half, whole numbers like 1 or 0, or they are, again, the special angles are radicals that have the square root of 2, the square root of 3 involved. So if you square those numbers, so if I square this answer, then I'll get the square of the number that I'm looking for. So this is 1/2, and so I'm looking for the square root of a half. So the square root of a half, you can take the square root of 1, you get 1. Take the square root of 2, you get the square root of 2. And then you could rationalize that, multiply top and bottom by the square root of 2. And that could also get you your square root of 2 over 2. Alright, so all three of these numbers are the same. They're all the same number. It's just if I want the calculator to help me, because these exact values will oftentimes have a radical in them, the square root. How do you get rid of a square root? You square. So we'll get a number that does not have a radical in it, and then we have to bring the radical back. We're not looking for the square of the answer, we're looking for the value. So we're going to have to take the square root, we're going to bring the square root back to this fraction that we get. Right, so that's the process to do that. It would accept either of these. It most likely will not accept this. You do need to simplify it at least to get rid of the radical for the 1. The square root of 1 is 1. That's how I got rid of that radical.